So learning target is I can determine the arc length and sector area within a circle using radian measure. Alright? Well, first of all, what are those things? Say I got a circle. You know what an arc length is? Anybody got an idea? Has a little bit of something to do with what we were just doing.
It's like a little part of the circumference.
It's a part of the circumference, okay? So, like if I want to know how far was it from there to there, okay? That is called an arc length, okay? I want to know the length of that arced segment, okay? It's a part of the circumference, okay? So arc length is a part or fraction of the circumference. Okay? Arc length is basically a fraction of the circumference. And the other thing I said we want to know is sector area.
The area of the fraction.
So instead of dealing with length, it's going to deal with area. So this is sector area. And sector area, if I wanted to give it a definition, I could say what? Look at my definition for arc length.
Fraction of the area.
Fraction of the area, yep. I heard you, Caleb. That was brilliant.
I almost had it. Close up. Area.
Fraction of the area. Okay? All right. I got that? Give me an idea of what those things are.
Why is it a fraction? What do you call it?
Because it's like part of the whole. You know, on an old test, if there are 100 multiple choice questions and you got 70 of them right, what fraction did you get right? 70 out of 100. What fraction is this? Well, that's a part. It's a chunk out of the whole thing. Okay? And the real reason why I use that for my definition is so I don't need to memorize the formulas that the book gives me. Okay? I'm going to give you the formulas, but I don't use them. So, arc length. The formula the book gives is S equals R times theta. Okay? S is your arc length. R, take a wild guess, we're working with circles. Radius. And theta is your central angle measured in radians. It's your central angle measured in radians. Alright, so for example, you might get a problem that says find the arc length. They'll tell you the radius is 8 centimeters and and they might tell you that the central angle is 3 pi over 4. Okay. Now, if you like the formula and want to memorize the formula, yeah, it's very, very simple. You just plug it in straight to the equation and you got it, okay? Which I'm totally fine with. Thanks. Okay? It would be that simple, okay? If you have the formula memorized, it's S equals R times theta. Your radius, they told me, was 8. The central angle is 3 pi over 4. If I take 8 times 3 pi over 4,
You get 6.
I get 6 pi, right? 6 pi, what do I do, centimeters? And that's it. Okay? 6 pi centimeters. Now, as a decimal, pi, remember, is about 3.14. If you take 6 times that, you're going to get roughly about 19. Okay? Alright, just shy of 19 centimeters. Which, that should make some sense. Okay? If I draw a picture to go with this, I got a circle. It said the radius was 8 centimeters. And it said my central angle was 3 pi over 4. How big is 3 pi over 4? Give me a rough estimate. Or maybe you know it exactly. 135 degrees is a little bit short of 1 pi. So in the circle, we'd probably be looking at that length right there. Does that visually make sense? 3 pi over 4, about 135 degrees. So I'm looking at this length right here. That's what I'm trying to find. Okay? Well, how far is it all the way around the circle? How far? That's how many degrees there are. 2 pi r, so how much?
16 pi.
C equals, I use pi d, but if you want to use 2 pi r, go for it. How far is it all the way around the circle? 16 pi. Okay. That's how far it was all the way around the circle. Was our answer a little bit less than half of that? Yeah. So that should make some sense. Okay? But again, if you don't have the formula memorized, you could definitely get by doing it another way. This is probably the way I do most of it. Okay? Maybe not with this one, because I do have r theta memorized. It does make it very, very simple. Okay? But remember how I said this is a fraction of the circumference, right? Mm-hmm. I want to know what part of the circumference that is. Well, the ratio of this over the entire circumference would be the same ratio as this over 2 pi. It's the same fraction. Okay? Or in other words, you could think of it, if I take three pi over 4 divided by 2 pi, and I take that times the circumference, I'll get my answer. Because what I'm doing is I'm seeing what fraction of the entire circumference I have. That just logically makes more sense to me, so that's kind of why I do it that way. Okay, you can memorize the formula, that's totally fine. I'm just giving you another method. Okay? You guys would agree this is a part of the entire circumference, right? Well, what part of the whole thing, or what fraction of the whole thing? Well, the angle is 3 pi over 4. Well, what fraction of the entire circle is 3 pi over 4? Whatever 3 pi over 4 divided by 2 pi is. That's your fraction, because that's your part over the whole.
Would it be the same thing as 135?
135 over 360. Yeah, if you'd like degrees better. And that's where you might like this method better when I give you the angle in degrees. Because when I give you the angle in degrees, you can't use this unless you change your degree measure to radians and then use this. This only works when you're in radians. Okay? And that's kind of why I always do it this way, because I never had to change them. I just had to think, okay, well, what fraction of the whole thing do I have? Alright? Well, 3/4 pi divided by 2 pi is going to be 3/8. Because 3 pi over 4 divided by 2 pi is like 1 over 2 pi. It's like multiplying by 1 over 2 pi. When you divide by something, it's like multiplying by the reciprocal. The pi's cancel, and what do you get? 3/8. Okay? So really, this is just saying I have 3/8 of the circumference. Well, what is the circumference? 16 pi. What's 3/8 of 16 pi? 6 pi. Okay? And that's confusing for you. You don't need to use that, okay? It just, to me, if I'm trying to find a part of the whole thing, I just take the fraction of the whole thing that I have and multiply it by the whole thing. Okay? Because I have a fraction of whatever. If I said you got 60% of the 40 questions right, how many questions did you get right? What would you do?
0.6 times.
Take the percentage, the fraction, right, 60%, and multiply it by the total, right? That's all I'm doing right here. I'm taking the fraction that I have and multiplying it by the total. Okay? But if you don't like that, if that does not make sense to you, then just flat out memorize the formula and use it. Okay? If I'm confusing you with that other method, don't use it. Okay? If I give you a degree measure, before you can use this, what do you have to do? Change it to radians. Okay? If I gave you a degree measure this way, it's actually a lot easier. Like if I gave you the degree measure of 135, just type in 135 divided by 360, because that's the fraction of the circle you have. So 135 over 360 times 16 pi. Get your answer.
Could we always just change it to a degree and then...
Could you always change it to a degree and then take that over 360 times the circumference? Yes. Sometimes that'll be better, sometimes it won't. Like if I told you the angle measure was 5 radians. Well, 5 radians is not an exact amount of degrees, so you'd be working with a very long decimal, but you could do it. That's why sometimes I do use this formula for something crazy like that, because if they tell me that's 5 radians, and they tell me the radius is 2, the answer is 10. I mean, without having to do any work there. If they give you a nice radian measure, like a whole number, then I just use that. So, I do it both ways, but if they gave me degrees, like if they said the central angle was 72 degrees, I'd probably write 72 over 360 times whatever the circumference is and call it good. So I'm trying to give you both ways. Are you guys seeing the connection here? Yes, no?
Yeah.
Some of you? Okay. Everybody got one way they feel like they could do it? Okay. Sector area is the same thing. I tell you to find sector area, and maybe let's say I tell you the diameter is 12 feet, and the central angle is, let's just go pi over, we'll go pi over 3. well, visually, what does that mean? It's 12 feet across. So the radius is only 6. Our central angle is pi over 3. That's about how big, or exactly how big?
60.
60 degrees. So you're working with something about right like that. And we want to find the area of that sector. That's what we're trying to do. Okay? There's the book's formula, 1/2 r squared theta. You're welcome to use it. I'm going to take the fraction times the total area. What fraction of the whole circle am I worried about? Don't give me degrees. Give me radians, but we can do it in degrees. What fraction of the whole thing do I have?
3 pi, 4 over 2 pi.
No, this
Pi over 3.
pi over 3
Over 2 pi.
out of 2 pi, right? Because that's the part I have, and that's the total. So pi over 3 over 2 pi, I'm going to take that fraction times the area. Area. Because remember, this is a fraction of the area. Okay, so here's my fraction of the area. That's what I would do. Instead of memorizing the formula. Yep, I know, it's easy. I know my radius is 6. That's pi over 3. I get it. It's easy. Anytime I can get away without memorizing a bunch of formulas, I do it. I try to use my prior knowledge to help me figure it out. It makes sense to me that this is just a part of the whole thing. Here's my part. I have pi over 3 out of 2 pi. I have, in degrees, 60 out of 360. If you want to change it to 60 out of 360 in this case, do it. Okay? And then take that times, now, you do need to remember the area formula of a circle. Pi r squared. Okay? So, if the radius is 6, 6 squared is 36, so 36 pi. So the area is 36 pi. Pi over 3 out of 2 pi is 1/6. So really you have 1/6 times 36 pi. Completely coincidental that this answer is also 6 pi. Label feet squared.
So every 76 pi.
And that's obviously way different because that's how many square feet you would have versus a length. The last one was a length. Arc length is always a length. Okay? So, again, here's your formula if you want to use the formula. Otherwise, just do the same thing. Take the fraction times the total area, just like you did fraction times the circumference, whichever way works for you. Okay? The practice problems are on page 349. Page 349, 34 to 52. Page 349, 34 to 52.